This video is showing some examples of parallel lines and transversals. So for each of the examples below, we're going to identify the type of angle pairs present. We're going to set up an equation to solve for any missing variables and calculate the measure of each marked angle. So for example 1, we have two parallel lines because we have the markings that show parallel. We have angle 1 and angle 2, and we have an angle measurement of 125 degrees. So first we need to figure out what the angle pairs relationships are, and then we can figure out how to solve for them. It doesn't matter which one you start with. So if we wanted to start with, let's say, angle 1, because we have 125 degrees, it's touching the transversal and one of the parallel lines. If we go to angle 1, we want to touch the transversal and the other parallel line. So that means it has one of those 5 relationships. The question is, which one? 125 and angle 1 are on, so 125 is on the top left. So it's on the top of the parallel line and on the left of the transversal. Angle 1 is on the top and on the left-hand side. So both of these are on the top left. Since they're in the exact same location, just on different levels, these are corresponding angles. So angle 1 and the 125 degrees are corresponding. And the numerical relationship between corresponding angles they are congruent. So if they are congruent, that tells us that the measure of angle 1 is equal to 125 degrees because they have to be the same degree. That's our first missing angle. Now if we go to angle 2, we can look at the same thing. So we have 125 degrees and angle 2. If we see 125 and angle 2 are actually touching the same parallel line, so it's not one of the 5 relationships that come from parallel lines. It's one of the other 2 that comes from the same parallel line. These are considered a linear pair. So angle 2 and the 125 degrees are called a linear pair. The numerical relationship between linear pair they are supplementary to each other. Kind of went off the little box. Supplementary. What that means, supplementary, are 2 angles, no more, no less, that add up to 180 degrees. So my 2 angles are 125 degrees plus the measure of angle 2, because I don't know what it is equal to 180. So if you were to subtract the 125, you'd get the measure of angle 2 is equal to 55. We have both of our missing angles. We found the relationship between them, we found the numerical relationship between them, and we set up an equation if needed, and we solve for all the missing angles. Example 2 is underneath here. So we want to figure out, we have 2 angles, and we have variables in them. So we have to figure out the variables, and then we have to figure out what the angles are. The first thing is you find one of your angles. I'm going to basically highlight it almost. Going to mark it. I have one angle. Then I'm going to highlight the other angle basically. Just going to outline it almost. And then I determine the relationship between them. Now this angle up here touches one parallel line and the transversal. This angle touches the same transversal and the other parallel line. So it should hopefully have one of the 5 relationships. This angle is on the left of the transversal. This angle is on the right of the transversal. And they are both inside. So they are alternate, and they're both inside the parallel lines. Therefore, they are alternate interior angles. The relationship is alternate interior. Now, because they are parallel lines, because of these markings, they have a very special numerical relationship. Alternate interior angles are congruent if they are from parallel lines. Therefore, we can actually set the two angles equal to each other. So we have x plus 15 is equal to 2x minus 30. If we were to solve this, we would subtract the x over, so we'd have 15 equals 2x, subtract the x would be a 1x minus 30. Then we would want to add the 30 over, so we'd end up getting x is equal to a 45. We have the value of x, we solve for the variable, now find the missing angles. Plug 45 in, 45 plus 15 is 60 degrees, so we have this is 60 degrees. Now alternate interior angles should be congruent, so we can check to see if this worked. So 2 times 45 is 90, minus 30 is 60. So we did this correctly because these two angles are in fact congruent. Moving on to number 3, coming up here. Now as you can see, these lines are not extended, but you can extend them. That is not wrong. The parallel lines, you can extend them to make them longer, and the transversal as well, because if it helps you to be able to see that. I'm going to again outline the angles that were given. So I'm going to outline this angle of x. I'm going to outline this angle of x minus 26. Now I want to see if they have special relationship. This angle x is touching the transversal and the top parallel line. This angle is touching the same transversal and the bottom parallel line. So since they're touching different parallel lines, they should hopefully have one of the 5 relationships. This x is on the right-hand side of the transversal, so is the x minus 26. So they're on the same side of the transversal, and they are both inside the parallel lines. That means that they are same side interior angles. Same side interior. You might hear same side as being called consecutive interior. I say same side so that it goes along with supplementary. I'm using alliteration. Same side supplementary, because these are going to have the numerical relationship of supplementary. But same side interior could also be considered consecutive interior. So since they're supplementary, that means you can add the two angles up and equal them to 180. They add to equal 180. So the first angle is x plus, the second angle is x minus 26, and it's supposed to equal to 180. The supplementary are two angles that add to 180. So x plus x is 2x minus 26 is equal to 180. We're going to add the 26 to the other side. So 2x is equal to 206. We're going to divide by 2, so x is equal to 103. So now that we have x equals to 103, I'm just going to go over that in my red because that's my answer. We can go up here and actually check them. So x would be 103. And then x minus 26. This would be 103 minus 26, which will give you 77. Now we can check, do these two angles add up to 180? They do, therefore we were correct in our math and in our relationships. Moving on to example 4, we have multiple lines crossing here. We still have two parallel lines. These are the two parallel lines because we have the markings here. Therefore, we have two transversals, but they're still crossing parallel lines. So we want to focus on letters that match. So the first letters that match are the x's. So let's focus on the x's first. So I'm going to outline the angles with the x. So this is my first angle. I'm going to outline that one because it's in that corner. And then this is my angle 5x. I'm going to outline that one in that corner. So now focusing on just that purple right here, I have on the right-hand side and on the left-hand side of a transversal, so they're alternate. I do have them touching different parallel lines, so that's good. So that means that hopefully it's one of those 5. These are alternate, and they're both on the outside of the parallel line, so they're alternate exterior. So the purple ones I'm dealing with here are alternate exterior angles. The numerical relationship is they are congruent to each other. That means that we can actually set them equal to each other. So we have the 3x plus 34 is equal to that 5x. So I'm going to subtract the 3x. I'm going to get 34 equals to 2x. And then we're going to divide by that 2, so we get x equals 17. Now we're going to plug them back in. 3 times 17 plus 34 is equal to 85 degrees. And we do 5 times 17 is also 85 degrees. So that means that we did this correctly. They were congruent. Now focusing on the y's, I'm going to outline those in a different color and use pink. This is my y angle here, so I'm going to outline it in this color. Then I have 2y. I'm going to outline that one as well. Now these are actually touching the different parallel lines, so that's helpful. They are on the same side of the transversal, but they are one's interior, one's exterior. That would think corresponding. So let's look at the 2y. This is on the bottom left, and this one is on the bottom left as well. So that means that these are in fact corresponding angles. The pink is corresponding. The numerical relationship is congruent for those. It means we can set those equal to each other as well. So we have 3y minus 35 is equal to 2y. So if we subtract the 2y over, we have y minus 35 is equal to 0. But then we have to add that 35 back to the other side, so it's y equals 35. Plugging them in. 2 times 35 is 70. And then 3 times 35 minus 35 is also equal to 70 degrees. So these were congruent as we said they should be. Going on to number 5. We have 2 parallel lines and 1 transversal. So we just want to outline the angles again. So my 3x minus 44 is inside of this angle. The x minus 24 is actually drawing an arrow to this angle, so be careful about that. It's actually outlining this top left angle. So if we look at these, they're touching different parallel lines, so that's helpful. This is on the top of the transversal, and so is this angle. They're on the top of the transversal. So they're on the same side of the transversal, but they're inside the parallel lines. So those angles are same side interior. And the numerical relationship between those are supplementary. So we can set the 2 angles added up to be equal to 180. So we have 3x minus 44 plus the x minus 24 equals to 180. 3x plus x is 4x. Negative 44 minus 24 is negative 68 equals 180. Add the 68, we get 4x equals 248. Then we're going to divide by 4, and we'll get x is equal to 62. We'll plug it in. 3 times 62 minus 44 is 142 degrees. Then we have 62 minus 24 degrees is equal to 38 degrees. 142 plus 38 is 180, so that does work. This last example also it's a shape, so you might want to extend the parallel lines in the transversal or just outline what you have and see what you're working with. So again, I'm going to outline my angles. So this is my first angle. It's pointing to here. So I'm going to outline this angle. It's a kind of it's actually a rather large angle because it looks like it's definitely more than 90 degrees. But then this angle is in this little corner. So I have a smaller angle here. So we can say that these probably will not be congruent. But this pink is touching a parallel line, and this pink is touching the other parallel line, so that's good. These pinks right here and right here are actually touching the same line. That's your transversal. The line that they both touch is your transversal. So the question is, where are these located? Now, this arrow is on the bottom of that transversal, and this arrow is also on the bottom of the transversal. So these are same side, and this arrow and this arrow are in between the two parallel lines, so they are same side interior angles. Same side interior. So again, they are supplementary to each other. So we can set them up. Your first angle is x over 2, plus your second angle is 7x, and they add up to equal 180. Now this is really half of x, so this is half plus 7, so that's really just 7.5, or like 7.5, 7 5/10 x is equal to 180. You don't have to make it complicated because you see fractions. It's just 7.5, which is 7.5. So now we just divide by 7.5, and we get x equals 24. Now if we plug them back in, 7 times 24 is 168 degrees, which makes sense because that's supposed to be obtuse. And then 24 divided by 2 is 12 degrees, which also makes sense since it's an acute angle. 168 plus 12 is 180 degrees.